Hello, hi guys. Am I audible to all? Just let me know in the chat if I'm audible. Okay. Like is he replying to me or this comment? I'm not sure. Hello. Okay. Video started. So I think I'm audible. Alright. So hi everyone. Today we will discuss the solutions. Sorry, this is the wrong. Just a minute. Yeah. So hi everyone. Today we will discuss the CF round, which was Div 1 plus Div 2 of today, and we will discuss these problems from A to D because I solved A to D, and even E was solvable. So if you want to try E, then also you can try. And like there is one assumption that you can take, and after that it becomes pretty easy. But I did not assume that thing, so I could not solve it. But yeah, so we'll discuss A to D. All right. But before that, I'll tell you about our courses at TLE Eliminators. So as you can see, um, if you are someone who is stuck at like solving only one or two problems per contest and want to level up, then you can check out our self-paced courses. These courses are divided into 4 levels. So whether you are a beginner, intermediate, pre-intermediate, or even advanced, there's a level for you. All right, and in each level, there are certain topics which we will teach through recorded video lectures by educators who are very experienced. All right, and also with each course there are many more benefits like these. That is, we have PCDs. They are open, but yeah, and curated practice problems in the course. Then we have internal coding contests for each level, and if you have any doubts, then you can reach out to any mentor on Discord. So instant doubt support on Discord is available, and the mentors are also quite good. As you can see their profiles here. All right. So yeah, if you want to level up, you can explore these courses. And in case you are not sure which level you should choose, you can watch this video to figure out. And if you are still unsure, then you can watch the course specific video about the syllabus and all, like what is what it will teach, what it will teach. All right. So, anyways, let's start it now. Let's start the PCD now. So, first of all, we have this problem A, which is called deranged deletions. Call an array B of length m a derangement if the following property holds. Let C be an array of length m such that Ci is equal to Bi for all I. Then sort C in non-decreasing order. If Bi is not equal to Ci for all I, then B is a derangement. For example, 4831 is B, then C is 1348 after getting sorted. Since Bi is not equal to Ci, in all positions B is a derangement. If B is 321, then C is equal to 1 to 3 after sorting. Since B2 is equal to C2, as you can see, B is not a derangement. You are given an array A of length n. In one operation, you can delete an element from A. The order of the remaining elements is preserved after each deletion. Output whether it is possible to perform some, possibly none operations such that the remaining elements form a derangement. If it is possible, then output any possible remaining array. The remaining array must be non-empty. Okay. So what you have here, just a minute. Yeah. Okay. So what we have here is we have a problem in which says that we have been given an array A, all right, and we have to we can delete any elements from this array A to make it an array B, all right, and this array B must be a dearrangement. Okay, and what is dearrangement? It is that if you sort B, then at no index the numbers are equal, right? So for example, this 3 to 1 is not dearrangement because when you sort it, the index 2 is same, it is 2, like the value of b2 and c2 are same, right? So you want to print any dearrangement like after deleting some elements from A. So for example, if you have 45524, okay, so in that case they have printed that you can delete 1 5, like this 5 you can delete, so you will get 4524, and this is a dearrangement. Why it is? Because the sorted order is 2445, and as you can see that all are unequal, right? So it is a dearrangement. But in fact, if you did not delete anything, like if you just kept it this way, then also it is a dearrangement. So 24455, it is a dearrangement because none of the indexes are same, right? So even if you print this array, then also it is fine. So in the output you just have to print the final array that you are getting, and it has to be a subsequence of the initial array. Like you have to delete some elements and not change the order of the remaining elements, right? So now what you can do in this is that one crucial thing to observe is that to they haven't asked us to delete the least number of elements or something like that. Like if the problem was that we should delete the minimum number of elements that we have to, like we have to minimize the number of elements that we delete, then the problem would be much harder. But in this case they have not specified anything like that. They have just said that you can delete as many as you want, just that final array should be non-empty, like it has to have at least one element. So why not make it, like why can't we just make it a very very small array? Like that is very somewhat easy to solve, right? So let's say that finally we make the array have only length 2. Like let us just delete all the other elements from the array and just leave two elements. Like if we have an array A of length n, then we'll delete all the elements except two elements and make this array b1 comma b2. So we have this b array now, right? And for this to be a dearrangement, what is the condition? Okay, guys. So what is the condition? Like how will we decide whether it is a dearrangement or not? So can you guys tell me this b1 and b2, for this to be a dearrangement? What's the condition? B1 is greater than B2. Yes, exactly. If B1 is greater than B2, then when you sort this array, it will become B2 B1, right? And that's why if they are not equal, then it is a dearrangement, right? So what you will just do is you will try to delete all the elements except for 2, and uh, just print any two elements such that B1 is greater than B2. But it also has to satisfy that this b1 comma b2 is a subsequence of this array A. Like let's say we have 3 1 2. So in this case you cannot print 2 comma 1. That is not a correct output, because this 2 comma 1 cannot be obtained from this array, this input array, by deleting some elements, right? So you have to ensure that your b1 comma b2 is a subsequence of your array, right? So basically, you just want two elements in your array. Let's say AI and AJ, AI and AJ, any two elements AI and AJ, such that AI is greater than AJ, and also AI appears before AJ. That is, I is less than J, right? So you just want any such elements, or basically this is called inversion, right? This is called inversion in an array where I is less than J but AI is greater than AJ. It is called inversion. So you just have to print one inversion in your array, right? But what if you don't have any inversions? Like, what if in your array, for every I and J, AI is less than equal to AJ? So that means that the array is sorted, right? If for every ij, AI is less than equal to AJ, that means the array is sorted, right? So, but in sorted array, whatever we do, like whatever elements we remove, the final array will also be sorted, right? Like if I have a sorted array 2, 3, 5, 7, if I delete any elements from this, like any subset of elements, if you remove from this, then also, like let's say for this, or let's say just these two, or this one, the remaining elements are always sorted order, right? Obviously. So therefore, they cannot be a dearrangement, because when you sort them and compare, all the indexes will be equal. But you don't want any of them to be equal, right? So if the initial input array, if it is sorted, then the answer is no, right? Because any subsequence of this will also be sorted, and any sorted array can't be a dearrangement, right? And if it is not sorted, then definitely there exists two elements, AI and AJ, such that AI is greater than AJ, and also I is less than J, right? If it is not sorted, then you have an inversion in that array. So we will just print any inversion, right? So that is pretty easy to print. Like you just have to even print the values only. You don't have to print the index, that where do they occur. Have to print the value only. So it is pretty simple. Like what I did, there are many methods to do this, but what I did was that I just iterated from I equal to 2 to n, like assuming one indexing. I iterated from I equal to 2 to n, and for every I, like I just saw that current element is AI, right? So um, from the elements, like from A1 up to A of I minus 1, in these elements, if there's any element which is greater than AI, then I'll just print that. I'll just print that element and AI. And for that, I just maintain that what is the maximum element in this prefix. So if the maximum element is greater than AI, then I'll just print maximum and AI, right? And before that, like if it is sorted, then I just printed no, right? So that's the entire logic here. So should I repeat any part, or do you understand? I sort by sorting the array and removing the elements that are the same for any index array. Akash, I'll take these general doubts after the PCD. Yeah, Sagnik is so this thing, like I have not thought about this, but it might be correct. So let's think about that. Like Joe, did it pass? Did this pass? But yeah, it should pass. Like it makes sense. Like if you have 1, 2, 3, or sorry, 3, 2, 1, let's say. If you have 3, 2, 1, then after sorting, it becomes 1 2 3. So if these 2 and 2 are same, you will just not print them and just print 3 comma 1. Yeah, that is fine, that is correct. If ai is greater than a of I plus 1, then we can just print ai and ai plus 1. Okay, yeah, true, that is right. That is a nice solution also. Because if it is not sorted, like if the array is not sorted, then definitely there is some index which will have ai greater than a of I plus 1. Yeah, okay. So I'll just show the code that I did, but even this works. So first of all, I have int n c in n and input the array a, and if a is sorted, if is sorted a, then I'll print no and I'll return, right? Otherwise, I'll print yes, and I will keep the prefix maximum. Okay, so ma equal to 0, and for all I from 1 to n or 0 to n. So in this case, I'm doing 0 to n. Like for I equal to 0, this will not be true because ma is 0 initialized. So it doesn't matter. So for I equal to 0 to n minus 1, if ai is less than ma, so that means there is some maximum value in the prefix of I, like 0 to I minus 1. So we can print that maximum value, and then we can print the AI. So I'll just print 2 MA and AI and return, right? And otherwise, like I'll update the prefix maximum. Okay. So this is the code. You can just look at it for 20 seconds. I'll give you. Okay. So if you have a doubt in the code, then you can ask. What is the time honesty of this? It is O of n, because this is sorted, works in O of n, and this is a for loop of n size, so it is just O of n. Why facecam today? Because I thought I was looking good. Okay. Expected rating of each problem. For that, you can use CList website. So you can see here rating is not calculated yet, but I think by the end of this PCD, it will be calculated. So you will be able to see using that. Okay. Anyways, yeah, I gave the contest using my main account, and I lost rating because I did not guess the correct solution in E. All right, let us move to the next problem now, which is called minimize sum. You are given an array A of length n with the element satisfying ai from 0 to n. You can perform the following operation at most once. Choose two indices I and j such that I is less than j. Set ai to ai plus aj, and then set aj equal to 0. So at most once you can do this. Output the minimum possible value of mean of a1 plus mean of a1 comma a2 up to mean of a1 to an that you can get. Okay. So the problem is very simple. They are saying that we have an array. We have an array a1, a2 up to an, and we can do one operation like at most once. And what we can do is we can choose an indices I and j such that I is less than j, and replace ai with AI plus AJ and make AJ equal to 0. Okay. And we have to minimize the value of the sum of prefix minimums. Like basically min of A1 is just A1. Okay. Plus min of A1 A2 plus min of A1 A2 A3 and so on up to min of A1 A2 A3 up to AN. Right. So we have to minimize the sum of prefix minimums. Okay. So samples, let's see samples. So here, um, first sample is 1 comma 2. So in this case, you can just not do any operations. Okay. So if you have 1 comma 2 and you don't do anything, so in that case, what is your answer? Your answer is minimum of 1 plus minimum of 1 comma 2, which is just 1 plus 1, which is 2, right? And let's say if you did do an operation, if you did an operation, then of course you have to choose I as this and j as this, because you have to choose I less than j, right? So in that case, what would the array become? You would do like you would add 2 in this and make this 0. So the answer would become, like the array would become 3 comma 0. And in that case, what is the answer? The answer is 3 plus min of 3 comma 0, which is 0. So which is 3, right? So yeah, so the optimal approach is to not do anything. So the answer is 2 in that case. So okay, in second test case we have 1 2 3. So in this case what we'll do is we will add this 3, like we will choose j equal to this one and add it to 2. Okay, so the array becomes 1 5 0. The array becomes what? 1 5 and 0, right? So the answer is what? 1 plus 1 plus 0. 1 plus 1 plus 0, right? So the answer is 2. And in this case, 3023, we can simply not do anything and the answer would be 3, because 3 plus 0 plus 0 plus 0. All right. Okay, so how do we solve this actually? So the way that we can solve this is like by having one observation. Like this is a very important observation. What is it? What it is that we have an array A1, A2, A3 up to AN, right? When you do an operation on some index, like when you choose some index as your index j, that means your index I is somewhere before it, like either here or here, right? But when you choose some index as the j, you will make it 0, right? You will make that one 0 and you will add to AI the value aj, right? So you will make this 0. So that means when you are taking the prefix minimums, any minimum after this one will be 0 only, right? Like for example, if I have 1 2 3 4 5, and if I take j as this one and let's say I as this one, it becomes 15045. Now if you take the prefix minimums, then what will it be? It is 1 for this one, then for these two it is 1, then for these three, like I mean for these three it is 0, then after this also it will remain 0 only, of course. So wherever you choose j, after that in the prefix minimum array, it is 0 only. So in your summation, like when you add these values for your answer, these values will be 0 only. Okay. So that is very powerful thing that you just made all the terms 0. Like just choose j as a certain index and make all the terms 0. That is very powerful thing to do. So you can just try that. So let's say in your array you have, let's say you have 6 elements: 1 a1 a2 a3 a4 a5 and a6. Okay. So let's say you choose j as this one because you want so that you want that maximum number of these prefix minimums become 0. So if you choose j as this one, 0 will come here, and any prefix minimum after this will be 0, right? So if you choose j here, you have to choose I here, right? So in that case, the array would become what? The operation is that you have to do ai plus equals to az. So this first element will become a1 plus a2, and this element will become 0, and after that they will be same. So the prefix minimum is what? So the prefix minimums, like, okay, I'll just write the entire thing for understanding. Now if you take the prefix minimums, this is a1 plus a2, right? The minimum of this one element. Then min of these two is 0. Then iske aage all are 0. 0 0 0. So if you find the answer, it is a1 plus a2. Like, this is one possible answer that you can get if you do I equal to 1 and j equal to 2 operation. Like, if you apply the operation on these two indices, then you will get this a1 plus a2. Okay. So can you do better than this? That is the question. Now, one thing to notice is that a1 to I, like, what is your expression? Your expression is min of a1 plus min of a1 a2 plus up to here, right? So this min of a1 means what? A1. So definitely you will get a1 in your answer. So this a1 cannot be avoided. But can we do something better than a2? Like, what if, can we get the answer just a1? Can we do that? No, that is not possible, because that would mean ki here they are all zeros, right? But that would mean we did an operation on, like this one. We did an operation on I equal to 1 and j equal to 2. But in that case, the answer is a1 plus a2 only. Okay. So we cannot get a1 as our answer. Okay. But can we do something better? We can actually get 2a1 as our answer also. Like, here instead of a2, we can get a1. How? Like, if a1 is less than a2, if a1 is less than a2, then if you don't make these 0, like, let's say if a1 is less than a2, then of course, um, 2a1, like, 2a1 is better answer than a1 plus a2. See, what I am saying is, one answer we got as a1 plus a2, and we are thinking that can we do better. So first of all, we cannot do a1, like a1 is not possible. A1 is not possible for our answer. But if a1 is less than a2, if we had a1 plus a1 instead of a1 plus a2, then that is very nice, right? So can we have a1 plus a1? So yes, that can happen if we do the operation from third. Like, if these two terms, this term and this term, are alive, and from this term onwards, it is gone. So, like, for example, if we have 3 5 7 9, in that case, what we can do is, we want a1 plus a1, that means 3 plus 3. So we will make these two as 0. So what we'll do is, we'll do an operation on this index. So it will become 3 12 0 0, and your answer becomes 3 plus 3, which is 6. So here you are able to get 2a1 because your a1 is less than a2. Okay. So if your a1 is less than a2, then you can get 2a1 also. Because when you do the operation, like, if you have, in general, if I say a1, a2, a3, a4, if you do the operation on, like, j equal to 3 and I equal to 2, then your final array would be what? A1, a2 plus a3, 0, a4, right? And you know that the minimum of these two is just a1, right? Because you knew that a1 was less than a2. So of course it is less than a2 plus a3 also. So the minimum of these two is a1. So your answer is just a1 plus min of these two, which is a1, and plus 0 plus 0. So you can get 2a1. So basically, if your a1 is less than a2, the answer is 2a1. And if a1 is greater than equal to a2, then you can just perform the operation on j equal to 2 and I equal to 1 and get a1 plus a2. Okay. Or in short, you can say that the answer is a1 plus min of a1 comma a2. Okay. So is it clear, guys? Basically, we are just trying two things in our array. We are only trying two things. Either we are doing I equal to 1 and j equal to 2. This will give us a1 plus a2. Okay. And my I equal to 2 and j equal to 3. This will give us 2a1 if a1 is less than a2. All right. So this is the answer. We could do a1 plus ax. No, but then in that case, uh, your a2 would already also be there, right? Like if you do a1 plus ax, uh, like let's say, basically you are saying that I equal to 1 and j equal to 5, let's say. So in that case, your array would be like this: a1 plus a5, then a2, a3, a4, and 0. So इसके आगे 0. So in this case, your answer is a1 plus a5 plus min of a1 plus a5 comma a2 plus min of these three, and so on. So I think I can prove that it is always worse. Like let's take two cases. Let's take a1 if a1 is less than a2. Okay. Then in that case, this term, this term will definitely be at least a1, right? This is greater than equal to a1, right? So therefore, in this case, we are getting our answer as 2a1, right? And your answer is a1 plus a5 plus at least a1. So it is greater than 2a1, right? So that is not optimal. So in this case, it is not optimal. And if we have a1 greater than equal to a2, then in that case, in this term, you will get a1 plus a5 plus a2, okay, plus some more things. But for in our answer, we were getting a1 plus a2. So here also you are getting a1 plus a2, but you are getting a5 also. So that is not optimal. Okay. So guys, do you get the proof now? Mr. Gatsby read. Please repeat the proof. So basically, if you like, I was replying to that one, Mr. Gatsby, that you can do a1 comma ax as well. Um, I'll just explain one more time. So what I'm saying is that 2a1 and a1 plus a2 is optimal. Okay. And like if you choose, let's say I equal to 1, and j equal to 5, then the answer that you will get is definitely worse than these answers. And why is that? Because see, this is the expression that you will get. Like this is your array, final array which you will make. So this is a1 plus a5, comma a2, comma a3, comma a4, and then afterwards it is 0. So when you have these terms, like in your answer, first term would be a1 plus a5, then it would be minimum of a1 plus a5 comma a2, right? And then there are more terms, but let's ignore them for now. So if a1 is less than a2, then we were getting answer 2a1. Okay. Now if you see carefully, since a2 is greater than a1, their minimum, like this value is definitely at least a1, because this one is at least a1 and this is also at least a1. So their minimum is also at least a1. So this expression is definitely more than 2a1, because here we have one a1, another a1, and we have a5 as well. So this expression is definitely more than 2a1. So it is not right. And if a1 is greater than equal to a2, then in that case we were getting the answer a1 plus a2. So what you are getting is a1 plus a5 plus a minimum of this. So minimum will be a2. If a1 is greater than equal to a2, then min of a1 plus a5 comma a2 will be a2. So what you are getting is a1 plus a5 plus a2 plus something, and just these three terms are already more than a1 plus a2, right? So therefore a1 plus a2 is optimal. Okay. Anyways, so the code is pretty simple. Like just take the input and just see out a of 0 plus min of a of 0 plus, sorry, a of 0 comma a of 1. Okay, this is the code. Whether I did not do this, like I didn't think of this, so I just did a brute force in O of n. So you can go through this code, like, but it is very complicated, so I won't explain this. But yeah, anyways, yeah. So we have C. Alice has an array A consisting of n positive integers. The array satisfies the beautiful property that AI divides A of I plus 1 for each I from 1 to n minus 1. Bob sees Alice's beautiful array and is jealous. To sabotage her, Bob first creates an array B of size n such that Bi is equal to Ai for each I from 1 to n. Then he chooses a positive integer x and multiplies some, possibly none, possibly all, elements in B by x. Formally, he chooses a subset, and for each I, he sets Bi to Bi into x. You are given an array B, but you don't know array A and the chosen number x. Please print any integer x that Bob could choose, so that multiplying some subset of elements of the correct array A by x would result in array B. It's granted that the answer exists. If there are multiple, then you can print any of them. Okay. So here we have an array. So the problem is that Alice had an array. Alice and Bob is there, right? Yeah, Alice had an array, just A1, A2, A3, up to AN. Okay. And they have said that AI divides AI plus 1. AI divides A of I plus 1 for all indices I. And actually, guys, आज तक मुझे याद नहीं हुआ that what does divide mean. So as you can see, I um, have searched, like in my other OS, I had searched that what does divide mean, A divides B. So it told me that AI plus 1 is a multiple of AI. AI plus 1 is a multiple of AI. Okay, so this array satisfies these condition. All right. Now what did Bob do? Bob just took some elements and multiplied them by x. Okay, and we have been given that new array. So I have to print the value of x. Like he just chose some elements, not all. So I have to print the value of x. Okay. So for example, if we have this case 2 comma 4. So in that case, wait, 343 is one possible answer. Okay, so Bob selected 343. This is a very okay. In this case, already 2 and 4, it satisfies the property, right? That 2, like 4 is a multiple of 2. So Bob did not change anything. So you can say that Bob multiplied by 1, as you can say. Okay. Then in this case, this is 1. Then this is 10 to the power 9, let's say. And this is 5e8. So you can say that Bob multiplied this number by 2. So x is equal to 2. Or you can even print 4. You can claim that he multiplied it by 4. Like initially here it was 25 into 10 to the power 7, and this is 15 into 10 to the power 7. So, or whatever, you guys get it, right? Like this by 4, its multiple is this number. So like if you have 1 10 50 or 1 10 5 or not, let's say 150. Okay, so in that case the answer can be x equal to 2 also, or x equal to 4 also. Like you can claim that initially array was 150 50. Okay, and Bob multiplied this by 2, so x equal to 2 is fine. And you can even claim that initially the array was 125 50, and Bob multiplied this by 4, so the answer 4 also is satisfied, right? So yeah, that's the problem that you have to solve. Okay, so this is like not very tough problem, to be honest. Like I can just, in fact I did this in 6 minutes, so I think, like if you sign, I took like 21 minutes in B and 6 minutes in C and 15 minutes in D, and then I could not solve E for 2 hours. That was very bad, but anyways. So yeah, what we have here is that we have an array. Like, see, the array has been given. Like in the input, they have said that they have given us the B array. That is, after multiplying by x, that's the array. Okay. So now, let's say we have been given this B1, B2, B3 up to Bn. Okay. So first of all, we'll check these two indices. Like, see, there are 4 cases. Okay. First case is that Bob multiplied x to both of these. Okay, so it became a1 into x and a1 into x. Or one more case is that Bob multiplied x to this number, like a2 into x, and this is a1. Or third case is that Bob multiplied x here, and fourth case is that Bob did not multiply anything, like Bob did not multiply x in these two numbers, right? Like initially our array was a1 up to an, and then Bob multiplied the number x to some of these numbers. So um, finally there are 4 cases that can be that Bob multiplied to both these numbers and they became these two numbers, or Bob multiplied to only one of them, or Bob didn't multiply to any of them, right? So if we know that a2 was a multiple of a1, if a2 was a multiple of a1, we knew, right? So if Bob multiplies x to both, then in this case also this b2 must be a multiple of b1, right? Like if a2 If a2 by a1 is an integer, that means a2 into x upon a1 into x also an integer, right? So this case it is no problem. Okay. Then a1 comma a2x. So if a2 is a multiple of a1, then of course a2 into x is also multiple of a1, right? Pretty obvious. In this case, we cannot say that, and this was just original, so it doesn't matter. But yeah, in this case, it might happen that after multiplying, the condition got violated. Like, for example, if we had the original array as 2 comma 6, and Bob multiplied this one 4, like Bob multiplied 4 into this number. So now in the input we have an array 8 comma 6. So since this 8 comma 6 does not, like, since this 8 isn't a factor of this 6, that's why we know that Bob definitely multiplied it to this number. Okay, that's my point. That if we see that b1 is not a factor of b2, that definitely means that Bob multiplied x into the first one but not second one, and that's why it is no longer a factor of the second one. All right. So till here, do you get this point? Like, this is one minor point, that if b1 does not divide b2, that means that Bob multiplied x in the a1 but not in a2. Okay. Okay. So how do we actually find out that what are the possibilities for x? So see, like here, let's say we got this 8 comma 6 in as the input. Okay. So in this case, guys, just tell me that what are the possibilities that can be there. Like, what are the possible numbers that I have multiplied? Like, what is the possibility of x? Let's say this was the input. If this was the input, then what is the possible value of x? Just let me know. Last test case of c. Okay, so this is pretty tough, but I'll try. Like, you can assume that this 6 was multiplied to these two numbers, then this number, and then I think this must be divisible by this. So I mean, yeah, you can figure this out, I think. Is there a way to find period rating change? Yeah, there is a extension called Carrot on Chrome. You can use that. So this extension is will predict your rating change. Anyways, for last answer, 3 could be correct, but why is it not being correct? Why can 3 be correct? Can 3 be correct? 73080 and 255780 will fail for 3. Okay, I think you got your answer. But anyways, where was I? I was at this point that, let's say your input array was 8 comma 6. Okay. So in this case, what are the possibilities of x? Just tell me, guys. So someone has answered um, 2, 4, and 8. 4 and 8. 4, 2, 4. Okay. So yeah, you are correct. Like, x can be 2 also, 4 also, and 8 also. Why? Because if it were okay, it cannot be 2. It can't be 2. Who said 2? Only 4 and 8. Because if it were 2, then this array would have been originally 4 comma 6. Like if x is 2, that means that Alice's initial array must be 4 comma 6, but this is not satisfied, right? So it can't be 2, it can be 4 or 8. Like if it is 4, then the array of Alice would be 2 comma 6 originally, and if it was 8, then it would be 1 comma 6. Okay, and both of these are satisfied, right? So anyways, in general, if we have b1 and b2, if we have b1 and b2, and we saw that b2 is not, like, okay, we saw that b2 upon b1 is not integer. That means that your b1 must be your b1 must be equal to a1 into x, and your b2 must be equal to a2. Okay, so basically your a2 upon a1 into x, that is not an integer, right? But you knew that this a2 upon a1 was an integer, right? So what can be the possibility of x? Okay, so basically the entire thing here is that you want to put certain x such that this a2 upon a1 turns out to be an integer. Okay, so let us write this in terms of b1. Like we know that b1 is a1 into x and b2 is a2. So here let's just write that. So instead of a2 I'll write b2, and instead of a1 I'll write this b1 upon x, right? So basically b2 into x upon b1. So essentially, you want that this b2 into x upon b1 should be an integer. So you want to put such x such that this b2 into x upon b1 should be an integer. So what is the value of x? Like in this example that I told you, b1 was 8 and b2 was 6, right? b1 equal to 8 and b2 equal to 6. So you can see that your 6 into x upon 8 is integer if x is equal to 2, or not, sorry, not 2, if x is equal to 4 or x is equal to 8, right? So that's the entire logic here, that you want to find out for what value of x will it be integer. Okay, so you will just check that b2 upon b1 into x, what's the value of x for which it is integer. So how would you do this? Tell me guys, how do you do this? GCD of a1 and a2. So are you saying that x will be GCD of, okay, and divide the number from a1? Yes, I think you mean b1 and b2, but yeah. So what he is saying is that what we will do is first we'll simplify this fraction. Like this b2 upon b1, they might have some common factors, right? So let's first cancel it out. Like we'll just divide them by the GCD. Okay, like here b2 upon b1 into x, we want all such x such that this is an integer. So for that, first we'll divide this b2 upon g and b1 upon g, where this g is the GCD of b1 and b2. Like basically what we are doing is we are simplifying the fraction. Like see, here we have 6x by 8, right? So we will write this as 3x by 4. Okay, because 3 and 4 are co-prime now. So what did we do? We just divided 6 and 8 by their GCD, right? So we got 3x by 4, and from here you can clearly see that to cancel out this 4, to cancel out this 4, you can have x equal to 4 or x equal to 8. So basically you need at least x equal to 4, right? So basically after simplifying this, like when you do this divide by GCD, to cancel out this b1 by g, you will need x to be at least b1 by g. That is, x should be a multiple of b1 upon g. Okay, so any x which is a multiple of b1 by g and it is less than equal to b1, it works. Okay, let's say b is 8, 9, 10. No, 8, 9, 10 is not valid input. Like they have said that they will only give such input in which the answer exists. Okay, bi can be to 1 in 9. Yeah, so what's your point? Okay, I think you're replying to this one. Yeah, so what I'm saying is that if you want, okay, I'll just repeat entire thing. Okay, like basically, let's say the input was b1, b2 up to bn, right? And you saw that b1 was not a factor of b2, but you knew that in the original array it was a factor, like a1, a2 up to an. Here you knew that a1 was a factor of a2, but after above multiplied by x, it was no longer a factor. So that means that Bob must have multiplied x into a1, right? So that means that your um, a1 is definitely b1 upon x, and a2 is definitely b2, right? And you want such value of x such that your a2 upon a1 is an integer, right? So what's the value? For that you will just put that right here, like you will just put these two values in place of a1 and a2. So a2 is just b2 and a1 is b1 by x. So basically this should be integer, and for this to be integer, this b1 factor should be cancelled entirely, right? Either by b2 or by x. So first of all, we'll just cancel out the common factor between b2 and b1. Like if you have 6x by 8, then you will make it first 3x by 4, right? And then you will comment that x has to be a multiple of 4 for this to be an integer, right? So first you will cancel this out, like you will divide by the GCD, and then you will say that x has to be at least b1 upon GCD for this to be an integer, right? So basically, when we saw this b1 and b2, when we saw b1 and b2, we figured out that x has to be a multiple of um, b1 upon g. Okay, so that's the entire condition of x, right? So we have one condition using this b1 and b2. Then we will use b2 and b3. Okay, then we'll use b2 and b4. Like, but we will only check those in which it is not divisible. Okay, like let's say if b2 were a multiple of b1, then I will just assume that Bob didn't multiply it at all. Like the best case scenario is that Bob didn't multiply it, right? So I'll assume that. But in all of those places where it is not divisible, I will apply this logic that x has to be a multiple of b1 upon g. Like if you're checking for b1 and b2, then multiple of b1 comma b1 by g. So if you have like multiples, like Let's say I'll take a test case. Okay, 4848, or not 48. Let's take something else. Let's take this one only. Okay, so we have 42, 44, 42, 42, 14, 84, 28, 73080, and 255780. Right. So you were iterated. First of all, these two pairs, they are divisible. Like this 42 is a multiple of 42, so it doesn't matter. Then for this one, 14 is not a multiple of 42. So what you will do is, you will check that 14x by 42, what is the value of x. So basically, in this case, sorry, um, we want that x should be multiple of 3. Okay. Then we have 14 and 84. It is fine. Then 84 and 28. So here also multiple of 3 it should be, right. Then these two numbers. This is too big of a number to for me to calculate. So I'll just use a calculator. So GCD calculator. Okay. So 28 and 730, 73080, 28. So that means that this is a multiple of 28. So this pair also is fine. Okay. But what about this pair? 73080 and 255780. 635 36540. So it is not equal to these two numbers. So that means that they are not divisible. Okay. So what you will do is, basically, if you want that 73080 and 255780, they work. For that, you will need that. Okay, this is your um, basically you will need that 73080. This is your B1, B1 and B2. So you will say that X is a multiple of B1 by G. X should be a multiple of B1 by G. So here B1 is this one, 73080, and GCD is 36540, right? So this is equal to 2. So basically, this condition is that X has to be a multiple of 2, right? And this one said it has to be a multiple of 3, and this also a multiple of 3. So that means X has to be a multiple of both 2 and 3. So it has to be at least 6, like a multiple of 6. So basically, all the conditions that we have, we'll take the LCM of that. Like we can just take the LCM of 2 and 3, right? So yeah, that's what we'll do. Like for all the numbers, B1, B2 up to Bn, we'll check all the adjacent pairs, and if it is not divisible, then we'll comment that X should be a multiple of Bi upon G. Like if you're checking Bi and B of I plus 1, then X should be multiple of Bi upon G, and you will just take the LCM of all the conditions, and that's your final X. Okay. So fine, guys. Do you get it? Okay, so I'll show the code now, and the code is very simple. Like code is pretty simple, so you will get it instantly. Just ignore this thing, okay? Like, just ignore these two lines. So what I am doing is, um, int n, c in n, input the array a, and then, sorry, I am iterating from 1 to n to check all the pairs. If a of I modulus a of I minus 1 is not equal to 0, that means it is not a multiple. Then x has to be a multiple of a of I minus 1 divided by GCD. Like here, if I have ai minus 1 and ai, then x has to be multiple of ai minus 1 upon g, right? So in this answer variable, I just take the LCM of all the conditions, and I just print the answer, right? It's that simple. Okay. So I will now move to the final problem, which was D. And D was a pretty nice problem. Like, I enjoyed solving it. But yeah, the rating of that is what I don't know. It is still in progress. So, anyways, it is a very nice problem. So you can try it if you haven't tried it yet. Okay. So the problem says that you are given an array A of size n and an integer k. You can perform the operation any number of times. Select two integers L and R such that R minus L plus 1 is greater than equal to K. Then select an index I such that I is between L to R, where AI is the kth smallest number out of the subarray AL to AR. If there are multiple possible I, you can select any. For example, consider A 1, 2, 2, 1, 3, L equal to 1, R equal to 5, K equal to 3. Then the third smallest number is 2, like 1, 1, 2. So you can either delete this 2 or you can delete this 2. And then you can delete AI from A and concatenate the remaining parts of the array. Determine if it is possible to get an array that's a palindrome. After any number of operations, note that an empty array is a palindrome. Okay. So what we have here is a very nice problem, as I said. So we have A1, A2, A3 up to AN. And what we can do is, in one operation, we can choose any subarray like AL plus 1 up to AR, okay, such that the length is greater than equal to K. Alright? And then what you can do is, you can delete the kth smallest element. Kth smallest element. Okay. And if there are multiple of them, you can delete any one of them. Alright. So you have to determine that can you make this array a palindrome or not using this operation any number of times. Okay. So first I'll show the samples for better understanding. So this one is already palindrome. Okay. This is a very useless sample test case. Then we have this test case. It is also pretty easy to see. I will take something which is not very easy to see. Okay. So let's take this one 1 2 2 1 2. It is, sorry, 1 2 1 2 2. Okay. And your k is given to be 4. All right. So what you will do is, let's say you will select the entire array. Like just select L equal to 1 and R equal to 5. Okay. So in that entire array, what is the fourth smallest element? It is 2, right? So you can delete any 2. So let's say you delete this 2. Okay, so now what you have is 1 2 1 2, right? And now again you will select the entire array. Like you will select L equal to 1, R equal to 4, and again the kth minus element is what? 2. So you can delete this 2. So you will get 1 2 1. Okay, so this is a palindrome, and that's why the answer is yes. All right. So this problem, we'll discuss it. So first of all, this operation, like this operation, select two integers L and R such that this array size is greater than or equal to k. Then select an index I such that I is between L to R. So this operation is very particular. Like we can actually simplify the operation. Like the operation that is given to us here is pretty complex. Okay, I can actually make it simple. Like under the hood, it is very simple. Okay, so simply what we can do in this operation is that in the array we can select any subarray of length greater than or equal to k. All right, and we can delete kth largest element from this subarray. So that's what we can do, right? Now my claim is that, okay, first of all, if you choose length equal to k, like see, you can choose any length greater than or equal to k, right? But if you choose length equal to k, then the k largest element in the array is what? It is just the highest element, right? If you see, like if you just choose a subarray with length equal to k, then what is the kth, sorry, kth largest, nahi, kth smallest? If you choose length equal to k, let's say, then what is the kth smallest number? That means just the highest value, right? Like for example, if you have some array 1 2 3 4 2 5 1 4, okay, and let's say your k was equal to be 3, and let's say you chose this length 3, like let's say you chose this array of length equal to 3. So in this case, what is the kth minus element? It is 5, right? First, second, and third. So you can delete this 5, right? So my claim is, like my point is that if your length of subarray, your length of subarray is equal to k, then we have to delete highest element. Okay, cool. All right. So that is done and dusted. Okay. But my point is, like my claim is that you don't need to you don't need to choose any subarray of length greater than k. Like whenever you are doing an operation, okay, you will always choose a subarray of length k only, and therefore you will delete the highest element uh, in that subarray. And like, why do I say that? Basically, my point is that whatever elements you can delete with this operation, you can definitely delete them by just choosing a subarray of length k. Okay, that is my claim. And how do I prove it? The proof is pretty simple. Okay, like I want to prove basically, I want to prove that all the elements, like any element. Okay, let's just give some names. That okay, if we choose a length k, if we choose the length k, then we can delete the highest element, right? So let us call this operation operation P1 or operation 1, let's say operation 1. Okay, and in the question, this operation, let's call it operation 2. Okay, this is operation 2. So my claim is like to prove that any element which I can delete using operation 2, or we can prove that any element which I can't delete, I can't delete using operation 1, I won't be able to delete that. I won't be able to delete it using operation 2 also. Like I won't write all of it, but my point is that this operation, in this operation we can select any size subarray, right? Not just length k. But what I am telling you is that if you just select length k subarray, then also you can do your work. Like my point is that any element which I can't delete using just selecting length k subarray, we definitely cannot delete using the length more than k subarray as well. Okay, that's my claim. So do you guys get my claim? I mean, I'll prove it. That why do I say so? But my claim is that always selecting a subarray of length k is the same as, like, it is not less powerful than to select a subarray of length more than k. Okay. So how do I actually prove that? Now, I thought of it during the contest, but I have forgotten it now. But I think I'll think of it again. So let's take some examples. So we want to prove that any element which I can't delete by taking a subarray of length k, I definitely can't delete it by having a subarray of length more than k. Okay. So for some element, like, okay, yeah, got it. The proof is very simple. Let's say we have an array a1, a2, a3, a4, a5, a6, a7. Okay. And let's say that k is equal to 3. Okay. And let's assume that we want to delete this a5, okay, from the array. So I want to prove that if I can't delete it by selecting an array of k equal to 3, then I definitely can't delete it using an array of k greater than 3, right? So I'll prove it by contradiction. Okay, like let's assume, okay, so basically I'll prove that any element, like I'll prove that any element which can be deleted by a subarray of size greater than k can also be deleted using a subarray of size equal to k as well. Okay. So how do you prove that? So let's say that choosing this 5 element subarray, by choosing this A5 gets deleted. So this means that A5 is the third element in the order of this. Okay, A5 is the third element in the order of this. Okay, this is interesting. Like let's say I had um, 4 here, 4, 5, 6, 7, and 1, 2, and 8, right? So in this case, how will I delete 4? Okay, I might be wrong. Damn. So how will you delete this 4? Using an operation of length 3. Like if you take this, then you can't delete it. If you take this, you can't delete it. If you take this, you can't delete it. But if you take this, then you can delete it. Ah, okay. I'm wrong. Okay. In the contest, I got very lucky that it is correct. Like my assumption is wrong. Okay. This entire thing, this is wrong. But what follows is correct. So I got very lucky. Okay. So let us just take this from the beginning. Okay, I'll maybe cut this part, or I'll give a timestamp in the in the comments that watch from here, don't watch from the behind. So guys, just forget what I said. Okay, I am saying that you can take any subarray L, R and delete the kth smallest element from it. All right. So my claim is that I have a new claim now. Okay. So let's say I have an array which has the elements 1, 2, 2, 3, 4, 4, 5. Okay. So and let's say k is equal to 5. Okay. And they are arranged in some order. Like I don't know what the order is. Like they might be in a different order as well. I just know that these are the numbers that in my array. Okay. So if k is equal to 5, that means whenever I do an operation, I will always delete the fifth smallest element. Fifth smallest element. Right. So what does that mean? That means that I can never delete these 4 numbers, right? Because they can't be the fifth smallest. Like whatever subarray I choose, they will definitely be less than fifth smallest. Like if I choose this subarray, this 3 is the second and 2 is first smallest. Like 2 is first smallest, 3 second smallest. But whatever subarray I choose, since these 4 elements are the smallest ones, they cannot be the fifth smallest, right? That is one point that is very nice. Okay. So if k is equal to 5, then that means you can't delete the first 4 elements because they cannot be the fifth smallest element. Okay. And my claim is that you can always delete these 3 elements, irrespective of what you have as the order. Like whatever order you have, you can always delete these elements. So I will prove that why. Like here k equal to 5, so you cannot, of course you cannot delete these least 4 elements, but you can always delete these higher 5 elements, higher 3 elements. So how? So let's say that you want to delete this 5. Okay, and 5 is somewhere in the array. Let's say 5 is here. And 4 is here, 4 is here, 3, 1, 2, 1, 2. Or, okay, wait, 1, 2, 2, 3, 4, 4, 5. So I have made one extra blank. My bad. Yeah, so let's say this is our array, and I want to delete this 5. So how do I do that? So to do that, you will just start your subarray from this 5, and you can just extend your subarray until you get 4 values less than 5. Like, since you want this 5 to be the fifth smallest element, right? Right now it is smallest. Right now it is the smallest element in this subarray. So what you will just simply do is you will extend this subarray until you get 4 elements smaller than that. Okay. So let's say you just extend this index, this boundary to here, and this boundary to here. So in that way, you can delete this 5. So you can delete this 5. But what about 4? Let's say I want to delete this 4 here. So how can I do that? So first of all, you will start out here, and then you will try to include 4 smaller elements. So like, let's say these 3 you will include. So you will move this here, and this 5 is greater, so it doesn't count, and this 4 is okay, less than equal to, it works. So if you just take this subarray, then the fifth smallest element in this subarray is 4. So you can delete that. So by using this algorithm, you can definitely delete any instance of 4, 4, and 5. So in general, if I say that if I have some k, then the smallest k minus 1 elements can't be deleted. Only the elements from k up to n minus 1, they can be deleted. Okay. And this is correct. All right. So sorry for the mistakes, but yeah, this thing is correct. That if you have some k, then definitely you cannot delete the smaller elements, but you can delete all the larger elements using the operation. All right. Okay. So now what we can do is, yes, correct. We will delete all the elements which are greater than k minus 1th element. Yes. Like, since we can do that, we will do that. But why is that true? That is also a question. Okay. So this was phase one. Like, phase one was that we proved that we could delete, we could delete any element greater than equal to the kth element. Like, for example, if we have 1, 2, 2, 2, 3, 4, and 5, and if k is equal to 4 also, then I can delete this 2. Like, I can delete any 2 and any higher number as well. Like, simply I can delete all of them. Like, I can delete any one of these. I just can't delete one. Okay, fine. But the thing is that I cannot have the array size less than k. That's also a thing. Like, I cannot have that my array becomes less than k length. Or basically, if it is less than k length, then I can't do any more operations. So it can't be less than k minus 1. Like, for example, if I have 3, 1, 4, 1, 5, 3, 1, 4, 1, 5, and k is equal to 2, then I am saying that I cannot have the array length, or let's say k equal to 3. Then I am saying that I cannot have the array length less than k minus 1. Because when I delete, like, let's say I delete this 5 by using this subarray. So I delete this 5. Then I delete this 4. Okay. Then I delete this 3 also. Now the array length is 2. And since I cannot choose any subarray of length 3, therefore I cannot delete any more elements. So the minimum length, like, basically the k minus 1 elements will remain. K minus 1 elements will always remain. Okay. All right, that is one thing. So now, is it like, do we just delete all the elements which are greater than k minus minus element? Just check if it's palindrome. I think that should not be true. Like, let's see the samples. Like in the samples, I don't think that is true. Yeah, so here you can see. Okay, it is not true. Why? Because you have multiple values now, right? Like just take this test case. 1 2 1 2 2 and k equal to 4. Okay. So what is the fourth element? It is 2, right? So you can delete 2 and any higher elements, right? But the thing is that there are multiple 2's, right? So which one to delete to ensure that there is a palindrome? Like you can only delete a certain number of 2's. Like you can only delete two 2's. See, since k equal to 4 and since k equal to 4, that means your array length can't be less than 3. So you can't delete all 2's. You can only delete two 2's, like either these two or these two or maybe these two, right? So this is where you have to be careful. Okay. So now what should you do? Like, okay, first of all, just delete all the elements greater than that value. Okay. Like if you had some 3 as well here, 3 3 4 5 or something, just delete them. It has no point to keep them, right? Like they can only interfere in a process of making a palindrome. So any elements greater than the kth element, just delete them. All right. Now, what about the kth element? You can only delete some instances of it, right? So basically, what you have here is that you have some smaller elements, like let's say um, 1 1 2 3 1 1 2 3, and let's say your k, or let's say one more 3. Let's say your k is equal to 5 or 6. K equal to 6. So the sixth element here is 3. Okay. So basically you have some elements which are smaller than the kth element. I'll call it val. Okay. I'll call it val. Sorry. Like the kth element in an array, I will call it val. Okay. So you have some elements which are greater than val. So greater than val, just delete them. Just delete all of them because you can. Right. Then there are values which are less than val. Less than val, you can't delete them. You cannot even touch them. You can't do anything. Okay. You can't touch them. But what about the values which are equal to val? You are equal to val, you can delete some of them. You can delete some of them. Okay. Like here you can see that we have three threes and we can delete two of them. Okay. Any two of them we could delete that. All right. So basically, since you cannot control these lesser values, of course they have to palindrome in themselves. Okay. Of course that has to be true because you cannot delete any of them. So in this case, you can just see that it is 1 2 1 1 2. So of course the answer is no here. Okay. But what about the, like, what if it was true? Like what if we had like this 1 2 1 2 1. So in this case, what is the answer? How do we check that? How do we check? Like we can delete at most two values of 3. Like we can delete at most two threes. So can we get a palindrome? How do we check that? So to check that, I have an algorithm. It's very simple. Okay. I'll just copy this one more time. 1 2 3 1 2 1 3 3 1 2 3 1 2 1 3 3. Okay. So what you will just do is you will keep two pointers. Like you will just look at the first and last positions of our array. So if you want a palindrome, then that means that definitely they have to be equal. These two have to be equal. But this is less than val and this is equal to val. So they are not equal. So you have to delete this val, right? Because you cannot delete this. You cannot delete this. So you have to delete this val, right? So now you will move pointer here. You have deleted this. Now again, this is less than val and this is equal to val. So you'll delete this. Now you are here. Now these two are both less than val and they are equal. So you will say that okay, this is fine, right? Then you will move here 2 and 2. So you will see that um, it is like they are equal, like they are both less than val and they are equal. So it is fine, right? And then you will move here. So now since we have already deleted two threes, right? So we cannot delete any more threes. But here you can see there is one val and one less than val. And since you cannot even delete one more val now, you are stuck. And therefore you cannot make a palindrome. Okay. So this is the approach that you can use. Like this is what I used, and I think it is correct. Okay. So the approach here is that just delete all the elements which are greater than val. Then less than val, of course, you cannot delete any of them. And the ones equal to val, you can delete some of them. Where some of them means that the array length cannot become less than k minus 1, right? And then you can just try to apply the algorithm. Like you can just do two pointers from both of the indices, and if you find an unequal value and one of them is val and one is less than val, then you will delete the val. But if you have already deleted many vals and you cannot delete more, then you are stuck. Then the answer is no. And also one more thing, if both are less than val, if both are less than val, but they are not equal, then also the answer is no, because you cannot delete any of them. Like you cannot touch less than val. So the answer is no in that case. If both are both less than val but unequal. Okay. So that's the entire approach. Yeah, I also put them in a DQ. Nice. So Timber, if you solved D, then why are you like watching this? Just curious. And meanwhile, others can also ask some doubts if you have. Masters, well, today I performed like CM level, but okay. Like I think I could have solved E if I had guessed that one thing that I had to guess. After that, if I like, I did guess it at the end of the contest, but it was too late for that. Anyways, that 17 figure pulled. That 17 figure threw me off. But anyways, so others, do you get the entire solution? Like I try to make it very rigorous. Already working, just CP for fun. Oh, nice. That is a very good way of doing CP. Like I also do it for fun only, and I also preach that in my college you should do it for fun. Let's solve it together now. In PhonePe, nice. PhonePe actually visits my campus as well. I think PhonePe does visit my campus, and one of my alumni, like from my coding club, so one of my seniors, they are also in the PhonePe. I think, but yeah, E. I think you are better off just watching the editorial or reading the editorial. I mean. So, anyways, do you have a doubt? Okay, before I answer this, I'll just show the code just to complete the PCD officially. After that, I'll talk. Yeah, so nk, C in nk, I'll take the vector v and then I'll find the kth smallest element. So I'll copy the vector into b and I'll sort it. So my val is b of k minus 1. Like why k minus 1 is it is zero indexing. Alright. So yeah, I get this val and then I just delete all of the um, values which are greater than val. So I just iterate over the entire array, and if ai is less than equal to val, then only I push it back into b. So I just reuse this array b. I clear it here. Now I have this array b, and I have to see that can I make it a palindrome by deleting the vals. Okay, so I just put it in a deque, and then I have this count variable b dot size minus k plus 1. So this is just like the current size of my array minus k minus 1. So this is the amount of vals that I can delete, and there is in a variable count. Okay. So while d dot size is greater than 1, if d dot front is less than val and back is less than val, then if they are not equal, then just print no and return. If they're equal, then just pop both of them. And if front equal to val and back equal to val, then just pop both of them. Otherwise, that means that um, one of them is val and one of them is less than val. So if I don't have any more moves, like if I cannot delete any more items, then I'll print no and return. Otherwise, I just delete the val. So if back is val, then I'll delete the back. Otherwise, I'll delete the front and count minus minus. And if this entire deque gets finished, then I'll print yes because I have mirrored palindrome just by deleting some elements. E was super difficult. Actually, it is not like if you just guess. Okay, spoiler alert. I'm just giving a spoiler for E. So if you don't want that, just leave the stream in 5, 4, 3, 2, 1. So in E, if you just guess that in only two operations you can do the entire thing to zero, then you can simply write a brute force. Like just check all the operations, like just check all of the indices I for the operation number 1 and just check that using that can you do the second one and make it zero. Like that brute force is kind of possible, but like I got this idea that let's guess that it is 2, but I it was very late, like I couldn't implement it in time. um red n, yeah, 17 was confusing. I mean, yeah, 17 was just to confuse because if they just had said 2, then it would be very obvious, like someone, most of us would just write a brute force. And I think most of the submissions in on this problem, like 1100 or 1200 submissions, they must have guessed only that the answer cannot be more than 2. Most of them must have guessed. They must not have proved it. But yeah, anyways, what? Yeah, exactly. Red N, it will be like in an hour or something, I guess. And the rating of D, maybe it will show here. Yeah, it is showing here. The rating of D is 1700. Okay, and E is 2000 rating. So it is pretty bad that I could not solve it. But okay. Anyway, so if you have a doubt now in any of the problems from A to D, you can ask. Oh yeah, intern prep, it is going fine. Like I have lost touch with CP somewhat because I am focusing on some other CS fundamentals and C++ and all. So but I am trying to get back into it because the OAs are CP only. So if you do well in OAs, then you can give the interview. So I am trying to get back into CP, but no progress yet, as you can see today. 1200 rank. Anyways, so any other questions if you have? Hmm. Okay, so I think solved 4, but rank was near to 20% because I was slow. Yeah, makes sense. In fact, I could have been even faster. Like, I solved C in 6 minutes and D in 15 minutes. But I took 20 minutes for B. And that was because I did not get the idea of that greedy thing, that A1 plus mean of A1 comma A2. So I wrote a brute force. Like, I did some calculations and like I checked for all J from 2 to N. That if for this J, if I do it, then what is the answer and all. Like, I did many things to solve this. But yeah, it was unnecessary. Anyways, so let's end the stream now. I hope you all got this. And if you have some criticism, then you can comment it, but don't really bash me for, like, just try not to demotivate me. But constructive criticism is encouraged. But yeah, so I'll see you guys later. Bye bye.